Today we will discuss differentiation of e to the power x and e to the power mx, a step by step for absolute beginner. First we will learn an important constant e. Like pi, the approximate value is 3.14. E has the approximate value 2.718, which lies between 2 to 3. This much is sufficient for absolute beginner. Now we are going to consider another function or the new function e to the power x, which is called exponential function of x. Next we will study the differentiation of e to the power x. So here we are discussing two forms. One is e to the power mx, which is more general form, and another one is a particular form e to the power x, where m is 1. So d dx of e to the power mx is m times e to the power mx. d dx of e to the power x is equal to e to the power x simply. So no change is here. Note that the derivative is m times the original function if m is present in the expression as shown here. Otherwise it will be simply e to the power x here. Some examples are given below using the same formula. d dx of e to the power 5x is equal to 5 times e to the power 5x, and d dx of e to the power 4 by 3x is equal to 4 by 3 e to the power 4 by 3x. A few more examples using the same formula. d dx of 1 by e to the power x. Here e to the power x appears in denominator. So we will take it to numerator. So here it will become e to the power minus x, which can be taken as e to the power minus 1 into x. So d dx of e to the power minus 1 into x is equal to minus 1 e to the power minus 1 into x is equal to minus 1 by e to the power x. Similarly, d dx of 1 by e to the power 3x is equal to d dx of e to the power minus 3x is equal to minus 3 into e to the power minus 3x is equal to minus 3 by e to the power 3x. So note that the expression here is first converted in this form e to the power mx. Then we can apply the formula.